need to do it again, but anyway, we are looking for speakers for Pittsburgh JavaScript. So if you have, also just generally for Code and Supply, so if you have cool programming topics, and especially if you have JavaScript topics, come find me or Justin. Either here in the Code and Supply Slack. By the way, we have a Slack. And this is Matt, and he's going to tell us about asynchronous programming in JavaScript.
All right. Hello. Can everyone hear me? I'm not the loudest speaker. I think we have a mic. So yeah, asynchronous programming in JavaScript. Nope. There you go. Cool. Can you all see that corner of the screen? Because that's where a lot of this can go. So asynchronous, I was looking online for a good definition, Cody definition of asynchronous, and then I came across the Greek etymology of it. A being not, sync being with, and then chronos, time, so not with time, which is a good explanation of asynchronous. The code doesn't necessarily run in the order top down. But asynchronous shouldn't be confused with parallelism. JavaScript is single-threaded and only can do one thing at a time. So the analogy I've kind of have in my head is someone juggling with only one hand. JavaScript can handle one thing at a time. It might have a lot of balls in the air, like different user interactions, different requests going in and out. If you're doing Node, you might have calls going out to a database. The actual JavaScript is only dealing with one of them at a time. But that does allow, since it can have the balls in the air and not be dealing with them, it can have multiple things going on concurrently. So the way JavaScript does this is with the event loop. So JavaScript, like most programming languages, has a regular stack architecture. So if you've just called one function, here you have cubed on the stack, and the variable is 3. It was called with 3 over there. And if anyone has any questions at any time, feel free to stop me. I'm happy to answer them. So whenever a function returns, its frame goes off of the stack. And this is more complicated, but the same general idea. We've called my super useful function plus squared, which is just going to add two numbers together and then square them. So plus squared goes on to the stack first, and then the squared function that's later called in plus squared goes on to it next. And then even slightly more complicated, the main thing this illustrating is the way JavaScript handles a lot of things with closures. So we have the inner function, when it's called for the first time, can see all of the variables defined in its outer containing function. So kind of breezed through those first few things to make up on time of it. Basically explaining closures in JavaScript. Is everyone with me so far? So here's where we get into sort of the asynchronicity of JavaScript. Whenever we call a function, it puts kind of queues up a task to handle for that event when it comes back, but still returns immediately. So if you were to run this code, request is sort of a placeholder function I have for making requests, just kind of a simple way. If you run this function, this little snippet, request return immediately. It doesn't return anything. The function doesn't return the response body immediately or anything. So this sort of executes immediately, but we have this sort of queue, this queued up task sort of waiting for an event to get back to it. In JavaScript, that doesn't block. So if you were to make two requests, one right after the other, it would send them both out. It wouldn't wait for the first one to return. It wouldn't block. They're both sent out into the world, waiting for them to come back. So now we get to, there we go, the event loop. So we have the JavaScript sort of runtime environment, and it has two just queued up tasks waiting for the request to finish. And then say both of the requests come back to the browser right away. So we have JavaScript, and then we have the event loop, which is either managed by, if you're using it in the browser, it would be your browser. If you're using Node, that would be your OS handling the requests for you. Just as an aside, does anyone here do browser-side or client-side JavaScript programming? How about working with Node? Node? So yeah, Node is just the server-side JavaScript implementation. So in here, previously we've sent off two requests. They both have come back immediately, and the event loop has sort of two events waiting in its queue to handle. The first event in the queue is sort of sent off from the queue back to the to JavaScript. The first handler receives it. It can do its thing. In this case, it's just gonna log it out. And then after that completes, the first event is out of the queue, and we're sort of back to the event loop looking for the next event. There's already an event there. And it sends it on back over to JavaScript, calling that handler function. And then once it finishes, there's no more events in the queue, and we're kind of done handling events. So that is a quick rundown of the event queue of JavaScript. Sort of to recap, so we have JavaScript, which can either it might have made a request and be waiting for a request, or events could be user input, users clicking on a thing. If you're using WebSockets, it could be a socket packet getting pushed back to like the containing browser, the containing operating system. And before JavaScript ever hears about these events, there's an event loop queuing up these events and then sending them one by one to JavaScript to handle. So JavaScript only processes one event at a time. And what's nice about this architecture is JavaScript doesn't need to wait for a request to finish before it can go on and move on to other things. So if you needed to pull back responses from two different APIs, you would send them both out at the same time. And then once they're both back, deal with them both once they've both finished. One thing about the event loop, events are processed in the order they get back to the event loop. If you fire request 1 off, and then fire request 2 off, and then the second request finishes first, that handler will be called before. So you're not guaranteed to handle the requests in the order you originally sent them. So that's.
When does it like pause normal synchronous execution to handle like an event? Is that just a regular thing on a frequency, or?
So that's a good question. The only time the event loop will actually be able to hand an event off to JavaScript is when nothing's happening in JavaScript. JavaScript doesn't have any concept of interrupts. It's single-threaded. So sort of the moment the JavaScript runtime isn't handling anything else, it'll ask the queue or the queue will tell it whether it has anything to handle. So if you've decided to loop over 0 to infinity in JavaScript, you wrote some bad code, didn't have a termination in your while loop, you'll actually just block the web page or the server forever. It won't get any of the events and it'll just queue up over and over.
Can I ask a follow-up there?
Sure.
So to clarify, you're saying that I send off in the AJAX request or whatever,
Mm-hmm.
and then some other code executes. I was under the impression that you're contradicting that and know better, that like it interrupts when it receives the response. You're saying that if it's busy, it's not going to actually.
Yep.
It's going to queue that response handler
Right.
until it's done.
Exactly.
That explains a lot.
Yep. Yeah. Which is both good and bad. So in JavaScript, the fact that JavaScript doesn't have interrupts is single-threaded means you never have to worry about like mutexes or race conditions of interrupts. So if you have a contiguous block of code that pulls things out of an object, changes some values, puts them back in, you're guaranteed that'll all complete in one go. You don't have to guard against, you don't have to like lock the object and then make sure that no one else is using it before you go ahead and use it. So that is the main conceptual overview of how JavaScript runs its event loop. Can I go back?
So,
Sweet.
so the event handler would be atomic. It would all have to complete.
Right. So
There would be no other interrupt.
exactly. So for example, in this case, if both of those came back almost right away, one right after another, you wouldn't be able to, you'd have no guarantee over which order those are going to be called in. But if you do complicated long code, handling the event, handling the response, putting in objects and like putting it out to the screen, you can completely handle the response, knowing that you'll be able to finish handling it, do all your cleanup, everything you need to do before any other requests are going to interrupt you.
You can also control the order by using promise all, right?
Sort of.
It creates an array that stops when it arrives.
We'll get to that. You can't guarantee the order that they'll arrive, but promises it will wait for all of the responses to finish and then give them to you in the order you called them. But they could have come back in any order under the hood. So those are event loops. That is sort of how JavaScript works. You set up your listeners, you fire off your events, and then you hurry up and wait for all of your responses to get back or for the users to initiate events. If you've worked with JavaScript for a while, this will be the same old song, but of course there are at least 3 different ways to do this, because JavaScript has been around for 22 years now. 95 was when it was first released to the world, and it's been the only game in town to run on browsers for a while. And it had a lot of rough edges, so it's had a lot of things smooth on top of it. So callbacks have been the way browsers have dealt with the asynchronicity of JavaScript forever. And also they were the original implementation in Node. Any browser can deal with callbacks. This is just baked into how JavaScript handles the event loop. You can write code this way for any browser, any version of Node. This is pretty much how it's guaranteed to work, sort of the vanilla way. I'm realizing, is everyone familiar with the shorthand of how to write functions in JavaScript? Basically, you might be used to seeing the function keyword in newer versions of JavaScript. Parens with the arrow is just a shorter, concise way to write functions, more or less. So this, we have sort of my succinct request function that's just going to make a request to /foo. And then it has a callback. This request is actually going to return immediately, and if I had code after it, that would continue on. But this function, the callback, is sort of just going to hang out in the ether until the event loop tells it, hey, the request you made, it's back. You're the function that was waiting for it, here you go. There's a common pattern, especially in Node, you'll see where the first argument will be your error. If it's null or undefined, then everything went as you expected, and you can safely use the other arguments. So this is just simply, if there's an error, we're going to handle it. Otherwise, we're going to maybe display the results to the screen or print them out somewhere. If you've used like jQuery's AJAX function has very similar, or one of its many AJAX functions, similar thing. Without proper management of it, there's a common pattern people will see, which some people call the march to the right, some people call callback hell, where you'll make a call, you'll have to wait for it to come back, but then you want to maybe make another request after that. So you make another request, and then maybe you need to do a third time. For the sake of brevity, I've only done 3 deep here. You could imagine if you have some complicated logic, you need to call back to some APIs, back and forth, back and forth, back and forth. You could wind up past the screen and indented many times in. And this isn't even handling errors. As you see, this function quite a bit longer than 1 line when you need to handle errors. Here, I'm assuming everything even just worked. If you had that if statements in here, you could imagine this being not pretty to read. There are a lot of third-party libraries to make this a lot quicker or easier, I should say. Async.js. If you're just using vanilla callbacks, which a lot of people prefer over promises or even the newer async await, async.js is a great tool. It will target the oldest versions of Internet Explorer that Microsoft still supports. It works on any version of Node. I highly recommend looking up async.js. Before promises were a thing, pretty much everyone was using this in any complicated code. So that is callbacks, sort of the vanilla default way to sort of deal with this asynchronicity in JavaScript. Does anyone have any questions or comments before we move on from callbacks? So the second way that a lot of people have been dealing with the asynchronousness in JavaScript has been promises. They were finalized with a final spec in ECMAScript 2015, which was the sort of yearly standard version that the JavaScript standards set on in 2015. But jQuery and many other libraries have been using things similar to promises for years and years before then. Though promises are supported in most browsers and most-ish versions of Node, they may not be supported if you need to target old versions of Internet Explorer. If you can't guarantee that your users will be on the latest version of Chrome or Firefox, it might be missing features. So promises aren't guaranteed to be fully implemented on your platform. However, you can implement promises entirely in JavaScript. So it's possible without any compilation to sort of polyfill in promises. And there you can be pretty terse with them. This is actually fetch is a built-in function in the browsers now. There are now 2 built-in ways in JavaScript to make AJAX requests. You have the default HTTPXR object, which I don't think anyone could tell you how to use off the top of your head. And now there's a fetch API, which is very easy to make requests. It's just fetch, you pass it a string. You can pass more complicated objects if you need to send in query parameters or post data or headers. But it is promise-based and baked into modern JavaScript. For promises, they're sort of callbacky looking. You have your promise, fetch returns one, and .then callback is how you get your data. It actually can only return one thing. In .then, there's only ever guaranteed to be one argument. Fetch returns a response object. Here we're just handling it. And then .catch will be called whatever function you passed in there if there were any errors. So this is actually a few more characters than if this was just a straight callback. But in this next example, you can see making 3 requests in a row, you don't have that march to the right that just vanilla callbacks would give you. You can make 1 request and then handle it. And if you return a promise in your promise handler, you can continue to chain .thens. Each one getting the response from the previous object, building upon it, and then firing off another request until the last one. And you don't have to deal with handling errors in any of them. If any of those return an error rather than a fulfilled promise, you just have to have one error handler at the bottom. You don't have to handle inline errors in every single callback. Come on, little remote. Does anyone have questions about promises before we continue with more promises? Sorry, fiddling with the remote. This is how, if you wanted to sort of promisify the request example function I had been using earlier, you could write your own, you can pretty much promisify anything that returns a callback or anything. Here, we're making our own fetch function, simplified to just take a URL, not handling posts or headers or anything. And then right away, it returns a promise. And then the constructor for a promise, you pass in a function that takes two arguments, resolve and reject. And this is how sort of you asynchronously tell the consumers of your promise whether or not things went well or not. Here, we're just wrapping the request function and then doing that same thing if the first argument is present, then we reject this promise. And if anyone consuming it had supplied a .catch handler, they would be called with whatever error you pass back to them. Or if you resolve the problem successfully, any .thens will be called with the response. And here's just an example using this sort of simple promisified function we've written. Does this make sense to, or does this look like magic or voodoo to anyone? So you can see how promises are sort of just sugar-coating callbacks. They're not adding anything to the language that you couldn't implement yourself. They're just a nice standard API that everyone can use to keep from marching to the right. And it has a few built-in also sort of APIs around it. There's the constructor to make your own promises. If you're using some API that's asynchronous and doesn't already use them and you're deep in the promise ecosystem, you can wrap pretty much anything in a promise. And then out of the box, promises also get you a few good APIs, and some of the ones I've used more often are .all. If you need to call 4 APIs and none of them are dependent, you can call fetch 4 times in an array, passing that array into promise.all, and then that itself returns a promise that will resolve with an array of results for all of them. And .race is very similar to .all, except rather than getting called with an array, you get called with the first one that returns. Useful if maybe you need to talk to like 2 different CDNs or n number of CDNs, and you just want to get back whichever one gives you the first result. And don't care about being mean and hitting all of the servers anyway. You do still have to be careful with promises. They make it easier to write readable code, or you could accidentally end up writing something like this. You should really always, in the then function, return a new promise. You should avoid nesting things like this. This won't do what you wanted it to probably. So you can write really unreadable code with promises. Avoid doing things like this. This is actually going to just immediately resolve with whatever foo returns. The second two requests will fire off, but no one's going to listen to them when they come back. So sort of a bad example of promises. And then next up, async await is the newest standard. In latest version of Chrome, it's built in. None of the IE versions support async await. And then Opera and Safari support them, but do a couple things in a non-standard way.
It comes with TypeScript too.
Yep. Yeah, TypeScript understands async and await as well. So a lot of times, depending on what you're targeting, unless you can pretty much guarantee that your users are using the newest version of Chrome or Firefox, or that you're writing this yourself and it's only going to be run in the newest version of Node, you'll probably have to use something like Babel or something else to transpile it into sort of something that all browsers can use. You can't just shim in a polyfill. Async and await actually add new keywords that change the language. They're fun to play with if you compare it all. If you care all about supporting old platforms, not yet recommended. But they're fun, so we're gonna talk about them. They make it super terse and super easy to understand. So this, there's a new keyword, await. Any function that returns a promise can be used with the await keyword. I have a typo. That should say const res equals await fetch. I'm also using, does everyone know const and let? They're the new versions of var. They behave more like a sane person would program a language. If you're not using let and const, I recommend looking them up. You won't shoot yourself in the foot with weird hoisting bugs. And they have block scope, like you'd expect. So const res equals await, and then fetch a URL. This will actually block on that line and await fetch to resolve the promise, and then behave pretty much like sort of any top-down programming you'd expect. What's also neat, you don't have to supply an error handling callback. You can actually put await in a try block, and if that function either throws an error or if it returns a rejected promise, it'll trigger your catch trap. So this starts to look a lot more like a traditional language. Async and await are kind of controversial. Some people think promises were too far and think we should have stuck at callbacks. But for better or worse, async and await are fully spec'd into the language, not yet fully supported. If you're going to start using them, the async and await keywords, you should A, make sure your platform will support it, and B, probably talk with your team before you start throwing in bleeding edge specs into your code base.
One of the benefits that you just mentioned nice and terse. It's like a one-line type of thing. But
Right.
when you add in the try catch, it gets look a little bit more like a then and the catch block or a promise. Are there any? Do you have experience in the past with like using a decorator function to paint that try catch picture, or is it pretty much mandatory to the syntax to do that?
You'd pretty much mandatory have to use it this way. Decorators, like actual decorators, aren't in JavaScript. They're built into TypeScript, which then compiles down into JavaScript. Though you don't have to if you have an even longer list of functions, I could have wrapped this whole thing in a single try catch. I wouldn't have to try catch each individual thing. So you only still need the one catch block, and if any one of those throw an error, it won't go on to the next one in an erroneous state. It'll immediately kick back out to the catch trap. So this does exactly sort of what you'd expect. It makes the first request and awaits it to return. And then the single next line without any extra function wrapping, no .thens, you can use the response. This is the string interpolation that's just making a request to /foo/ whatever was the first one in my imaginary array that first request returned. And you continue on, just no having to march to the right, no complicated functions to write. A lot simpler to write than promises. There is one super easy way to shoot yourself in the foot, and it can be kind of hard to debug. Without the await keyword, those functions just return regular vanilla promises. It doesn't like throw an error or anything. So if maybe in that last one you forgot to type await, it'll run. Your linter probably won't complain about anything, and you'll just be passing a pending promise into whatever function.
So fetch returns the promise,
Right.
but you don't need that for your function to return a promise. You use await. Like, what do I need
Right.
to do to make that function?
So if you want, can all of you see past it? It's not cutting off any part of the screen. Say because reasons you decided that you needed a function that squared any number you gave it in n number of seconds, is what this function will do. And it's just going to return a promise that n seconds later returns n squared. Super practical. I use this function everywhere. You could still use .then. You could call slow square 5 .then, and then 5 seconds later, your callback that you passed into then will get called. You can, if you decorate a function with async, you can only use await in the scope of an asynchronous function. Otherwise, your script would probably finish to the end and then just return, not awaiting anything. So here, we have our sort of function wrapping our asynchronous calls. I have a couple logging statements because in the next slide, I print out what this is going to return. But here, this is actually going to take about 5 seconds to run. We're going to call slow square with 2, and await is going to block on that line. It'll wait the full 2 seconds and then log 4, and then it's going to call slow square again with 3, waiting the 3 seconds and then logging again. For async await, I'm actually not sure if if you have a thing that doesn't return a promise, what it will do. I'm pretty sure if you just returned a number without doing any asynchronous things and you await it, you'll just get back the result. I don't think there's any harm in awaiting, but that's something I'll look up after we get through this and get back to you at the end of this. You probably don't want to await just every function, bad pattern.
It's
However,
pretty complicated to do that though, because you have to explicitly put that async in front of the function that would return the
if it returns a, you don't have to put,
I guess it could cascade.
yeah, you don't have to put async. So await has to be called within the scope of a function that's asynchronous, marked with async. But if the function, if you call a function that is either an async function, it's decorated with the, or has the async keyword in front of it, or returns a promise, the await keyword will do what you want it. So the sort of await either awaits an async function, and the async keyword actually just sort of wraps your function and makes it return a promise anyway. So you can dot then an async function, or you can await an async function.
It's sort of this syntax for the trigger, but now you don't have to have the dot then and like that.
Right. There's exactly, yeah, it is a lot cleaner. You can't take, there's no way without, you can pretty easily actually transpile code that uses async and await into promises, but you can't just pass them into a browser that doesn't know about them. But yeah, they are just syntactical sugar on top of promises. And then what this is going to print out, we're going to print out calling, which is that first thing that we call into. And then you see when I actually call async call, I'm console.logging what it returns. And before anything else runs, it actually returns a promise itself. So this function is called outside of an asynchronous scope. So you can await it and it will return immediately. But then inside, the 4 and the 9 will print out over the course of 5 seconds. Cool. So we had a late start. I went through this pretty quickly, but I think we've caught up and we have plenty of time for questions. And I do have a little bit more, but are there any questions about so far? Currently, we've gone over the event loop in JavaScript, which powers all of this. And then not 1 or 2, but 3 different ways you can do asynchronous code in JavaScript because this is JavaScript.
Async.js. I went to programming JavaScript, and that was, at that time. That was sort of before promises got in all the browsers.
Right.
You'd still recommend it for certain things?
Right. If you're using, if you're using an older code base that's all callback based, you can use async.js. The main Node APIs, I actually haven't used Node in a little bit, I believe are all still callback based. So the Node ecosystem is still there are now like sort of 2 camps of people who think callbacks were the way to do it, and promises add needless complications and are less powerful. And then there are now a lot of newer APIs, newer frameworks that use promises. So the number 1 recommendation I would give when deciding which of these to use is first, use whatever's in your code base already. Callbacks are perfectly fine and fun to use. Promises are also great. Async and await, while cool, are still probably not quite ready to target all prime time yet. And async.js, it does do asynchronous code, but has nothing to do with the async keyword. It actually long predated that keyword being thrown out there. So this sort of a summary of just general using JavaScript and its asynchronicity. There are a few common pitfalls you can fall into. The number one being, if you block the main JavaScript thread, either getting in an infinite loop where you don't properly terminate, or if you start doing expensive business logic in Node, like doing a lot of math, looping over many things, doing things you should probably be doing on the database side, you can start to block the main thread. And if you truly never return, you'll either freeze the tab in Chrome or Firefox or whatever, and you'll get the browser dependent version of, this tab isn't responding, would you like to kill it? Or if you're just being slow and doing slow things in JavaScript, user click events won't trigger until your JavaScript has kind of returned. Or you'll get, if you're using Node, requests will start queuing up if you can't get them out the door faster than they're coming in. So there's a few common, since there is no preempting, since it's all in one thread, you can block, sort of tie up the whole thread. And asynchronous, especially if you're new to JavaScript or this pattern, can be difficult to debug because things are returning before they're really finished. Promises and async await keywords try to make it cleaner, but you can still easily make a few character mistake, close your curly braces wrong, and still have code that appears to run but doesn't do anything you'd expect. Following best practices, having a good linter, the Chrome debug tools are all fantastic ways to debug these. But the asynchronous pattern, I think, gets you a lot, and there's a strong case for using it. Even, well, in browsers, you have to use JavaScript. But even if you have, there's plenty of choices server side, and some of the stronger ones for using Node. It is single-threaded, so you don't have to worry about mutexes or preempting. Your block of code is going to run from start to finish as long as you don't do any asynchronous things from start to finish. You won't get preempted in another part of the code, which sort of even just that tips the scale back to neutral, because dealing with race conditions are a whole other can of worms. And because JavaScript sort of, as long as the actual main thread isn't dealing with anything, it can have tons and tons and tons of balls up in the air. It can have thousands of open requests at any given time. Node is used a lot, especially with Socket.io, where you might have 10,000 users all connected to your server at once, all with an open socket. But very little of the time are bits actually going back and forth, which means most of the time one thread can be plenty to do with the handful of requests happening at any given time. So it's very cheap. Things like Ruby, PHP, their model, for any request or socket that's open on your server, it actually forks the entire process. So you get a whole process with the whole Ruby or PHP runtime sitting next to it. So hundreds of requests can start to eat up all of the resources on your server, and you'll have 100 threads all sitting there doing nothing. Whereas one node process can handle any number of requests as long as most of the time they're quiet. And Node, it's pretty easy to scale. If your server you've written can handle 1,000 requests a second, and you have 2,000 requests coming in, then you have 2 servers up and running. You don't have to worry about resource sharing them. It's really easy to linearly scale Node. You just open more servers. And that is sort of a whirlwind tour of JavaScript and how it handles asynchronous, and diverges from maybe more traditional languages. I'm happy to go back to the slides, answer questions. And I do have a bonus question. You may or may not see this on interviews. You may have asked this question yourself in interviews. Does anyone hazard a guess as to what this is going to do? It's initializing a variable to 0. It's looping 10 times while incrementing I, and then calling set timeout, which waits that number of milliseconds before calling the function passed into it. This is sort of how JavaScript deals with scope and asynchronicity all rolled into one. That is a good guess. It will print out numbers though.
Is it cheating if I just wrote this in the
No, but I can tell you what it's going to do as I wrote it. So this is actually, this is going to print out 11 10 times. So this initializes a variable to 0, and you have one kind of pointer to I. And then it's going to loop 10 times, incrementing I each time. And then that set timeout is going to return immediately. But you have sort of 10 functions hanging out in the ether, but with that same scope, because they've captured that I, but they've all captured the same I. So this is sort of a tricky question. It prints 11 10 times. Because the powers that be, when originally writing JavaScript, decided this was sane behavior. Yeah. Does anyone want me to go back to maybe even the earlier slides, or any questions, comments?
Can you go back to the one with the async await?
Sure, defining our own async await.
Yeah. Can you say again, like, when you need to out async things from where, like, you lost it?
Sure. So JavaScript will actually throw an error if you try to use the await keyword in a non-async scope. You need to be inside an asynchronous function to wait for it. Usually you won't have to deal with this, because if you're inside a Node framework or in the browser, you can just easily wrap. You'll see this kind of common for demoing async await, where someone just defines your async calling function and then calls it.
One slide that I saw that I don't think I heard you go over. There was like blocks, sort of, crossed out, sort of.
So earlier on I said that JavaScript always returns immediately. Ooh, it's so quiet now. The AC just turned off. Normally JavaScript returns immediately, and for a long time that was sort of one of the core tenets. You could tell everybody that as long as you reason about JavaScript always returning immediately, you'll be mostly there. Async and await sort of breaks that pattern. if you inside the async scope is when it breaks that, you can use the await keyword and wait for things. And the model gets a little bit more complicated there of what it's pushed onto the stack. But yes, that's why sort of.
I have a question that wasn't necessarily covered by your slides. And in my code, I'm dispatching actions in the Redux and GRX type pattern. And I'm curious if anybody here may have come across a solution to be able to asynchronously dispatch the next action after the first one has kind of completed all of its effects and mutations to the store.
It sounds like you're about to answer it, but
No, I don't know. I don't want
Well, it's
I
just
have a sort of an example I can show you.
yep.
You've come across it before?
I mean, I wrote it a couple weeks ago.
Yep.
There's
It's very
libraries
funny.
for it.
Yeah, there's a, I think Thunk is,
And Redux Observable is another one, and there's a Redux Epic or something like that. as
And
well.
what does it do?
Saga, that's the other one.
What does it do? It just basically puts it like kind of like a semaphore flag that says don't proceed to the next dispatch until.
It's an extension on Redux, since Redux doesn't natively support async redispatching, but we can talk afterwards, I think.
a web page somewhere. And it had about, it was just like that long, and it had all these different mixings made by things. And it's like everyone just like sort of made one a little different. It's like sort of like a forking an open source project.
Yep. Because in JavaScript, if it's worth doing once, it's worth doing n times.
Yeah, so I'm like, which one should I use, or should I just cut and paste from 3 different ones?
Did you have a question too?
Yeah. With nested thens, the other day I was dealing with a bug and couldn't end up finding what I was looking for. I ended up having to do something else to it. And for like simple version, it was say like an API call and then a really long then function, inside of which there's an API call, and a medium-sized then function, inside of which there's an API call and a then function. And to fix the bug, the easiest way would have been to just make something happen right at the end of everything else. And so I was like, okay, I'm pretty sure everything calls right away, so I don't think a finally at the end of the outside will do it. And sure enough, that called like right in the middle. So I was like, okay, well, the most logical place would be inside the innermost then function, and that called like 2/3 of the way down. And I'm like, what's actually last in that?
So hazarding a guess is, I don't see the code right now. So first, the best thing to do is to avoid that situation altogether. Generally, when you're using promises, you want to avoid nesting .thens in it. As soon as you're sort of using another promise, the best thing to do is return that new promise, and then you can chain .thens. My best guess as to what's happening there is, since the way promises sort of chain thens, it needs to know that you've returned another promise, and the only way it knows about the nested promise is if you've returned it. So if you say fetch foo, then your handler, and then inside there you say fetch foo or fetch some other route using information you originally got, .then. That then function and any nested then functions will continue to be called in a nested fashion, but you don't really have any hooks in to get the data back out, which I think might have. Is that making any sense?
Yeah, I get it. Yeah, what I ended up doing was rewriting the whole thing to a row.
Yep.
So, yeah.
Yeah, with code like that, maybe even taking the time to understand isn't a good use of time. Just rewriting it into a sane fashion will often just fix the bug. As once you start nesting thens and doing odd things with promises, they can be hard to follow. Just some people's arguments against it. Any other questions, comments?
So I'm new straightforward, simple kind of creating basic
Mhm.
and making these calls. Should I just stick with callbacks? Purely vanilla, but I'm not looking to do anything complex.
So my first question, are you using a framework like React or Angular?
Angular,
Okay. So if you're using Angular 2+, it has a built-in HTTP library that will play nice with other Angular-y things. That said, Angular is pretty modular in the way you pull in the different pieces of it. So if the fetch API makes sense to you, I've seen plenty of Angular application code that uses the fetch API. I think fetch is the simplest HTTP API I've seen for just making requests and then getting responses. And it's built into the browser. It's in most browsers already. And if it's not built in, there are many polyfills or Babel or tools to make it back to ancient versions of IE, even entirely JavaScript implementations of fetch.
So, you were talking about like async and await not being ready for prime time.
Mm-hmm.
But if you're using the transpiler, like Babel or something, would that?
Mm-hmm.
And is there any reason not to use something like Babel if you're using CS 2015? You're already.
So this depends if, my opinion, if you already have a build step and you're already transpiling your code, you already have Babel in the tool chain.
Right.
I think you should always target the latest version, greatest version of JavaScript. It's entirely possible for, and Babel does transpile the async and await keywords back into promises, and then it has a shim to polyfill promises into browsers that don't already have them. So if you already have Babel, entirely safe to use. But I don't think I would introduce Babel into a new code base just to use async and await.
Okay.
But if it's already there and you already have build step.
Or building something new, that makes sense with old code base.
Mm-hmm.
Thank you.
No.
Thank you.